Aloha and welcome to this screencast, Functional Programming in JavaScript for Java and C++ programmers. I want to try to give you guys a gentle introduction to a programming paradigm which is really awesome. And unfortunately, when you're kind of a beginner, novice Java or C++ programmer, you don't really run into it very much. It's only recently kind of supported in Java, and C++, the support is kind of painful. So it's not really taught or used much in those languages, even though it makes your life so much simpler. So I wanted to provide this introductory lecture and show you some examples and hopefully get you on the functional programming bandwagon, because it's a rockin' wagon. So if you just Google on functional programming, you get this kind of complicated description, a style of building the structure and elements of computer programs that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. Yikes, that sounds complicated. And then you find out what languages, Erlang, Haskell, F#, what the heck are those? That sounds, crazy. Well, it is crazy, and programming in a purely functional style is a radically different style of programming, because in essence you don't have the assignment statement. And once you throw away the assignment statement, it's kind of like retuning your guitar to a completely different, key or something, or a chord, like all your riffs go away once you don't have the assignment statement. We're not going to do that, because it turns out that in JavaScript, it supports a lot of the functional programming paradigms, but it supports it but doesn't force you. In other words, the assignment statement is still there. You can do assignment when you want. At the same time, the fundamental constructs, language constructs necessary to program in a functional style are provided and are easily usable in JavaScript. And there's basically three of them. One is that functions are just normal values like any other kind of data type. The second is that you can pass functions around as arguments to other functions easily. The third one is that you can return functions, new functions, as the value of other functions. Okay, so once you have those three things, you can have parts of your program be functional, or indeed, if you want it, just never use the assignment and then you've got a functional program, totally. But in this class, what I want you to discover is that there's a lot of situations in which using a functional style can reduce 10 lines of code to 1 line of code. And that means, 1/10 the opportunity for bugs. Plus, there's this really awesome library called Underscore, which once you understand these three concepts of functional programming, you can exploit this library to really simplify your code and just program faster, get done faster, which of course is the thing that we, all of us programmers want to do. We want to get done. We want it to be right, and we want it to be done, and we want to move along quickly. So that's what functional programming provides the opportunity to do. Okay, so here's the basic deal. Java and C++, the way you're taught it is that on one side of the world, you've got data. That's like your integer, your string, your byte, your array, your what have you. And then on the other side of the world, you've got functions, and you declare them differently from data, and you manipulate them differently from data, and they just seem like they're completely different kinds of things. Okay? And maybe if you've never even considered anything differently, if these are the only languages that you've used. You move to JavaScript, there's just data. Okay? Function is just another kind of data object. All right? And that kind of blows your mind at the beginning, but then in fact you realize, well, which diagram is more complicated? This one or this one? Well, obviously this is the simpler diagram. And so, in fact, programming this way is simpler. Pretty crazy. All right, so what I want to do is now, let's do a little demo so that you can get a sense for what this means. Okay, so here I am in JS Fiddle. And let's start off and declare a variable called I, and we're going to set it equal to 0. Okay, so that's our classic data object. Okay, now we can operate on that data, right? We can say I double plus. Okay, and then if we say console.log of I, what do you think is going to happen? Okay, we're going to get the value 1, right? We had an operator that we invoked on that data object, and it did something to that data object, and we see the result. Okay, let me ask you this. What if I did this? Whoops. What if I did that? Well, that would be stupid. That would be an error, right? Because I is a data object, and you can't invoke it as a function. And if in fact we go control return, we see, yeah, type error, I is not a function. Okay, what I want you to think, this is an easy way to suddenly transmogrify yourself into a functional way of thinking, is to say, just like if I was, foo, okay, I can't invoke the double plus operator on it. Okay, if I use this operator, parentheses, then I has to be a function to operate on it. Okay, so when I is 1, right, it's legal to do certain things to it, like I double plus. It's illegal to do other things to it, such as invoke it as a function. These curly braces are just like another operator on that variable. Okay, so let's say this. Okay, what if we said I was a function that returned 1? Okay, and then we invoke I, and in fact we'll invoke it right in here, or we'll do this. Okay, then we'll say let j equal to I, and then we'll print out j. Okay, we get a 1. Okay, so what I'm trying to show you here is that we can bind a variable like I to 1, or we can bind a variable like I to a function. If we bind I to a function, there are operators we can invoke on it, and it's this one is the most interesting one, which is the operator that says run that function. And the result of running that function, whatever the value it returned, we can now bind that to another variable and we can print that out. Okay? And just like we couldn't say something like this, double plus, that's not going to work, right? Because I is bound to a function. Okay, similarly, if I was bound to a variable, a number, we couldn't say that. Okay, so the parentheses, they're just an operator that says whatever variable I'm next to, that's got to be bound to a function, and I'm going to invoke that function, and the value of this entire expression, is the value returned by running the function. Okay, so that's what I mean by functions as values. They're just data objects. A function is just a data object like an integer, string, byte. You can bind it to a variable just like any other data value, and then there's certain operations that you can, just like you can only run certain operations on an integer, string, or byte or array, there are certain operations that are valid on a function. And in particular, the operation that we all care about the most is the parentheses. Okay, and of course the parentheses can have arguments, so that if we go, so we could say something like function, let I equal function num, return num plus 1, okay, and then let j equal to I2. What are we going to get? Right? Well, now we've got this operator. This operator can also take arguments, 0 or more arguments, and those arguments will be passed into the function. Okay, and if we run this, what happens? We get 3. Okay, because we passed into The value returned from this entire expression is 2 plus 1, 3. We bound that to j, and then we printed it out. Okay, so I don't know, am I beating a dead horse here? Okay, I'm just going over it and over it, because once you just see that functions are just another kind of data type, like any other data type, they're really more similar to integers and strings, you know, then they're different. You know, they're really just the same. And once you get that, then everything else I'm going to talk about just becomes totally trivial. Okay? But this is the key thing that has to be in your mind. Functions are no longer special. Functions are just a kind of object like a string or an integer or whatever. All right. Enough of that. Okay, so that's the functions as values part. Now we're going to go functions as arguments to other functions. That's the second piece of our functional programming paradigm. Okay, well, how do we do that? Okay, so let's get rid of this, and let's take as our example a function. We've got a situation where we want to take a list of numbers and add 1 to them. So let's say we have a list like 1, 2, 3, okay? And what we want to do is we want to add 1 to it. Let me make this a comment. Okay, so that what we get back is 4, 5, 6. Okay? And this is something that is a really generic, you probably run into something similar to this every single day or every other day that you program, where you've got a collection of things and you need to, you know, look at each of those things and then build a new thing based upon all the elements in your original thing. Okay, that's the general idea here. So let's just write this thing. So we want to add 1, so let's call it function add 1. And it's going to take nums, okay, which is our array. And we're going to say let new nums equals our return array. And then we're going to say for let num of nums, using our ECMAScript 6 iteration. We'll say new nums dot push num plus 1. And then we got to return new nums. Okay, so let's see. If we say console.log add 1 and then pass it our array 1, 2, 3, what happens? Does it work? I don't know. How good am I? I'm really good. Because that works, right? So I pass in this array of 1, 2, 3, and what I get out is an array of 2, 3, 4, where I've added 1 to each element of the array. Okay, so let's say we're programming and we had to increment, you know, we had this big long list of numbers. For whatever reason, we had to increment 1 to each of them. We wrote this thing, and then we program on for a couple more days, and then we go, oh darn, now today, for some reason, I've got a new function and I need to add 3. Okay, so I could write an add 3 function, you know, and change that 1 character to a 3, but that would be, you know, that would be lame, right? What you'd probably want to do is say, you know what, I'm going to generalize this. I'm going to call this add num, and then I'll say incval is how much I want to, you know, increment it by. And so I'll just change it like this, and then I call this add num, and then I say what I was supposed to increment by 3. Okay, so I try this out. Let's get rid of my old one. Okay, and 4, 5, 6. Okay, so this is cool. Now, you know, I can program for another week maybe, because I find out I have to increment by 7, increment by 8, and oh, my add num function is working super good. And then, you know, a week later, I get into a new scenario where I've got to double each value. Okay, and all of a sudden, oh my God, now I've got to write a double num function, and the only thing I'm going to change, it's going to be a complete copy of this, but now I've got to change this to star 2, and get rid of that inc val, All right, so then 2 weeks later I got to do a division, it just goes on and on. I'm going to have like 14 different variations of this silly function, all to manipulate my list of numbers in various ways. Okay? But that's your life if you're in Java or C++, is writing all these little variants to take, deal with all these different cases. JavaScript, because we now know that we can update, we can pass functions around, it offers a really nice, elegant general solution. Let's call this, I don't know, alter num. Okay, what we're going to do is we're going to pass in a function. Okay, and we're going to invoke that function on each number in the array and then push the result of invoking that function into the new array. Okay, so let's say our function is let add1 equal function num return num plus 1. Okay, so if that's our, we've just written our little function, we can say alter num 1, 2, 3, and then we can pass in our add1 function, and what are we going to get? 2, 3, 4. Okay, so now our alter num, and remember, we also were worried about what's the case, what about when we want to multiply or double the numbers? Let's say let double num equal function num return num star 2. And then we can pass in double num 2, 4, 6. Okay? Now the crazy thing is, this function now doesn't refer to any number-based operations at all, and because you don't see a plus sign in there or a star or anything like that. In fact, this is an example of probably the most canonical functional utility function out there. It's called map. Okay? Map is a function that takes a list, okay, in this case in JavaScript it's an array, and a function to operate on each element of the array and returns the result of invoking that function on each element. Okay, so I have these nums in here. I'm not going to edit them to call them elements, but what I want you to see is that we can now, I'll just, all I've done is just change this to be called map, right? So run this again, you see it works. Now what's crazy, let's change this to strings. 1, 2, 3. And then instead of, I won't bind I'll just put the function right in here, right? Function str return str plus, I don't know, I'll just do something to that function. Okay, now you can see our same function that was running on numbers before, okay, can also operate on strings. It can operate on anything. Okay, this is a completely general function. Okay, that's super cool, and that's all through the power of being able to pass functions as values and then invoke them inside. So we took that parameter called fn and we used the parentheses to say, hey, let's invoke that thing in there, and by the way, I'm going to pass it a value. So I have to, part of this function is saying, hey, guess what, this function up here, you better have defined it to accept a value because I'm about to invoke it with a value. So in the documentation for this map function, it'll say you're going to pass it in a function, that function needs one value, you know, and blah, blah, blah. All right. So there you have it. That's the first huge benefit of the functional paradigm, which is that we can now generalize, create these very general purpose functions that mean you no longer have to write 14 different variants of the same code, you know, which are all exactly alike except for tiny little pieces of it that you've, you know, cut and replaced to fit your different scenarios. You can write these much more generic things by virtue of the fact that you can pass in a function. Okay, so that's functions as arguments to other functions. Last one, functions as return values from functions. Okay, how's that going to work? Let's see an example of that. Well, let's say that instead of mapping, we're going to do something called filtering. We're going to take our numbers and we're going to pass in a function, and we're going to say for each element of our array, if the function on the number returns true, then new nums dot push num. Okay, and then return new nums. What we're saying is we're going to filter out all of the, we're going to take an array of things, and then we're going to return a new array, and the only elements in that array will be the elements for which this function returned true. So let's say we had our filter function, and we wanted to return let's say we had, you know, I don't know, a couple threes and, you know, a couple twos. Okay, and we wanted to say we want to return only the elements of the array that were the threes. Okay, and so we're going to pass to our filter function a function. Here's the function we're passing. The function returns true when the element that it's passed, which is going to be each element of this array in turn, is identically equal to the string 3. So what will happen when we invoke this? Let me get rid of this other stuff. Oops, let me get rid of this. Okay, we get the two elements that were exactly equal to 3. You know, and then of course we can do this with 2, and we'll get that, and we could say, you know, 6, and then we get that. So, you know, it works as expected. Okay, so let's say let is 6 equal to this thing. Okay, right, we've got a variable bound to a value, which means we could pass is 6 in here. Okay, and we could run it, and we get the empty string. And then we could have another one called let is, you know, 4. Okay, and that would be equal to this function, almost the exact same function, except we're checking to see that it's 4. And then we could pass, you know, is 4, and we get, do we have any 4s in there? No. Okay, so let's make a let is 3. Okay, and we make that function like that, and then we change it into is 3. Okay, and finally we get our 2 3s. Okay, now hopefully you're seeing something pretty crazy here, which is look at all this cutting and pasting. I've got these 3 variables bound to 3 functions. They're all exactly the same except for one character. Okay, so that's not good, right? That's the kind of stuff we want to avoid. There's this principle in software engineering called DRY, D-R-Y, don't repeat yourself. We're repeating ourselves quite a bit here. Okay, fortunately, with functional programming constructs, we've got a tool that can come to our rescue, which is the ability to return functions as the value of a function. Okay, well, how would that work? Okay, it's really a little crazy until you get used to it, and then you're like, man, this thing is awesome. Okay, what we're going to do is we're going to say function is num, okay, and we're going to pass in our, or is str, let's put it that way, and we're going to pass in our string, and then we're going to return a function which takes an element and that function is going to return true if element equals string. Okay? So now what we can say is we can replace is6 by is str 6. Okay? Because is str6 is going to return a function that returns true if the element is equal to 6. You see that? Let's see if that works. Okay, well, maybe it works. We should try it with is3, right? So, in fact, we can get even a little better. There's no reason to even bind these things anymore. Let's just go is str 3. Okay? And kablooey, it works exactly the way we want. So what we've just done is we defined a general purpose function that takes a value, returns a new function which uses that value in some way, and now instead of having to write all of this duplicate code to deal with all the different things we might want to check for, we've written kind of a general purpose predicate that we can pass to this filter function. So when this filter function runs, it's going to get this array. Okay, that's easy. But then it's going to invoke this isString function, isStr function with 3. That's going to return the function that it's actually going to use in its code right here. Right? So by the time where it's invoking this fn, it's got something that looks like this. Okay, where this value is whatever was passed in here. Okay, so you might want to rewind and go through this or copy this code and think about it a little bit, because it's kind of cosmic. And in fact, one of the things that's cosmic about it is that you might ask yourself, whoa, this is crazy. I passed in this 6 as the str, and then I returned this function, and that 6 somehow got bound, the str got permanently bound to the string 6 in there. That's pretty crazy. But what that is, that's an example of what is called closure. Very powerful idea and necessary for this whole functional programming paradigm to work, which is that you can capture the value of certain variables when you are doing this return of a function. And now that return function guy is going to remember that str, when it was invoked, str was 6, and just keep that bound so that it can use that later on, when it gets invoked here. Okay? But I think if you go through this, you don't have to get all technical about closures. You can just kind of work through this scenario and say, well, yeah, it's kind of obvious what's going to happen. I'm going to call this isStr3. That's going to return a function which compares whatever it's passed to the value 3. And, whatever, no big whoop. Okay? Okay, so that's functions as return values from functions. Really useful thing. So the last thing I want to just really briefly talk about is, well, what's with this underscore library for JavaScript? And the answer is that functional programming is a really old paradigm. Okay, it's at least 40 years old. You can trace it back to the lambda calculus. And, and people that use the functional programming paradigm have repeatedly realized that there are just some basic, functional idioms that you use over and over again. Map, okay, the one I wrote for you, that's like the kind of the number one functional programming construct. Filter is another one. There's another one called reduce. There's several. And that what underscore is basically the JavaScript, a JavaScript implementation of a bunch of these canonical functional programming idioms like map, reduce, filter, etc. And there's a whole bunch more that they implement that kind of exploits the various objects and data structures in JavaScript. So not every single one of the methods or utilities provided in the underscore library is a functional programming construct, but most of the fundamental functional programming constructs are provided someplace in the underscore library. And for every programming language that supports this functional programming idea, they're going to have map, they're going to have reduce, they're going to have filter, either provided as a core utility in the language that's just built in, like that's the way Lisp has it, or in languages like JavaScript, you get these external libraries which provide it. So there you have it. My simple introduction to functional programming. I hope that now that you've gone through this, play around with it a little bit through the underscore library, and you can go off and your JavaScript programs are going to go from this big, this big down to this big, because you're going to be able to use these crazy underscore libraries to write your code in a much more compact and reusable fashion.